Right, as you can see, this is Unit 5 review. Make sure to go back and rewind and as needed on this video. Fast forward if you need as well. Just go to the problems that you need to go over a little bit more in detail. I'm going to go through the entire review. That's all of our questions from this entire Unit 5 review. And so we'll just kind of go ahead and get started. Oh, goodness. Okay, so here's our first learning target. I can explain and interpret the definition of what a function is, whether you're saying yes, it is a function, or no, it's not a function, including domain and range and how to describe the domain and range of a function. Okay, here's our first set of our first question that we have. And it says, which of the following relations represents a function? Select all that apply. This particular equation is if you put an input here, so remember the input is all of our x values, and the output, whatever this equals, whatever y equals, each time is going to be our output. So for example, you could think of, if I take an x value and I put it in right here, I could take 5 and put in like a 0 right there. If I put a 0 into that spot, I would multiply 0 times 5, which is 0, and I'd get a 4 back out as my y value. All right. If I put a 1 in, it'd be 5 plus 4. 5 plus 4 is 9. So if I put a 1 in, I would get 9. And so each time I put in a value, no matter what I pick, negative numbers, positive numbers, no matter what I pick, I'm always going to get it to equal one value. So that is absolutely going to be a function. So yes, this is a function. This one actually has a special name. We call this a linear function. And we're going to learn more about that in the next unit. This one right here, not a function. Why is this not a function? Because the x values, remember what the definition for a function is. Each input needs to have exactly one output that it pairs up with. So you can't put in an x value and get two answers. You can't put in an x value and get two things that it could pair up with. So if the x values ever duplicate, then we would say no, not a function. All right, this one, yes. How do we know? There's something called the vertical line test, and the vertical line test is just a fancy way of saying, do each x values only show up one time? Do they show up twice? On this one, no. It only slices through, if any point that I scan my pencil across the page, it only shows up one time. All right, and so yes, this would be a function. This one, no, not a function. Why? Because this particular x value, these are x values, these are y values, this is called a mapping diagram. It goes from the input to the output, and it pairs up. So you're saying which ones pair up with which ones, and this one pairs up twice. If an x value pairs up twice, it means it is not working. It is not functioning correctly. That particular value causes the whole thing to not be a function, all right? And so one thing we kind of compare this to is if you're going to go and use a vending machine and you punch in D7, you only, if it's functioning correctly, you're only going to get one thing that tries to free itself in the vending machine. You're not going to get all the spindles to start spinning and shoot out a bunch of things at you. That would be multiple outputs for one input. All right. If you punch in D7, that means give me one exact thing. All right. And so take a look at this right here. 6, 9, and 12. We don't care if it's 7, 7, and 7. We care about this value, and this value. So are the x values unique? Yes, they are. So this would actually be yes, a function. So our answer on number 1 is A, C, and E. Okay, check out number 2. As I look at this particular equation right here, y equals 2x plus 8, what does that actually represent? It means that my pizza is going to cost some money based on some values that will go in right there. And the money it's going to cost is $8 for a pizza, plus $2 for every topping. And I know it's toppings because right here it says X toppings. You got to read the whole thing first and go through it, and it says a large pizza with X number of toppings. All right? So maybe 0 toppings, maybe 1 topping, 2 toppings, 3 toppings. You can even make a table of values. If it's toppings, right here, toppings, and money, those are the two things you care about. This is my X value, this is my Y value. All All right, and so if I put in 0 toppings, what happens? I put it in right there, 2 times 0 is 0, and I get an 8. It's gonna cost me $8 for 0 toppings. I guess that's a plain old pizza with nothing on it, right? What if you're gonna put 1 topping in? If I do 1 topping, it's gonna be $2 additional is what this is going to say. So $2 additional would be 10. So it's 8 plus 2. Okay, if I keep going, more toppings, every time I add another topping, it's gonna be $2 more and $2 more and $2 more, right? And so it's gonna be 2 toppings is 12. And 3 toppings is 14. There we go. Now right here it says where x is actually equal to, and it gives you a set of values for your x values right here. And it says 0, 1, 2, and 3, but it doesn't give you 4, 5, 6, 7, and on and on and on. And instead, maybe they give you a limit of how many toppings. I don't know. Why not 4 toppings? I don't know. For some reason, this problem doesn't give you more options than 3 toppings. All right. Identify the independent and dependent variable. The independent variable is always the x, and the dependent is the y, which sort of makes sense because the toppings, so let's write that right here. X value, or the x variable, is toppings on your pizza, and that's going to be my independent variable. We're going to call that x. All right? And in this case, this is my y variable, which is money. All right? Which one depends on the other one? If you get more toppings, then you're going to pay more money. The money depends on the number of toppings that you buy. So the independent thing is the thing you decide. You walk up to the cash register and you're like, I'm going to get a pizza with 3 toppings. You decided that, right? That's the independent choice that you made. What depends on that afterwards as a result? This is just another way of saying input and output. As a result, it's the output, right? So they have lots of names. Domain and range are kind of the same thing, x and y, right? The domain and range are actually talking about the numbers, though. If the numbers are, the number of toppings right here are going to be 0, 1, 2, 3, and those are the only number of toppings you can get, then what's your range that's going to pair up with that? The pairing up amount is 8, 10, and 12, and 14, right? So those are actually all of the values that could work on this particular problem. So we've defined our independent, dependent variable. Domain is the set of values, and the range is the set of values for the y as the money, right? So this is our output or our money value. All right, let's keep going. Okay, here's our next problem, which is really not that hard. It says, which point would you remove so that the relation can actually be a function? And remember, this is another way of saying, where does it actually violate the vertical line test? And so there could be a vertical line that would go right here, and notice these 2 points are on that same vertical line. So we have a problem with these 2 points. If they're on the same vertical line, then we say, no, it's not a function. Which one can you remove? Well, you could say E, you could say D, or as your answer, you could say E or D, if you're recognizing that it could be either one, honestly, could be removed. All right, so not too bad. This one's a little bit interesting, a little bit challenging, and it says which graphs below, or use these graphs to complete these. And it says which graphs. So you could have more than one potential answer on all of these. So let's check every single one of them and see which ones apply. Which graphs have a domain? Remember, domain is all of the x values. The x values of all real numbers. All real numbers just means that they go forever and ever, and it includes all of the x values. Now this one only includes x values from here to here. There are limits on this. It only has a certain span of values that work, so not all real numbers. Honestly, I wish this had arrows on each end, but if they're going to the edge of the graph, it is actually implying that they go forever and ever and ever in both directions, all right? So you could put arrows on yours, and that would be nice, because then it emphasizes it goes forever in that direction. Domain of all real numbers. This will spread out forever and ever and ever, and so it means all x values. Go to your x-axis, and which x values are represented here? Yes, all of them. because it keeps spreading out, spreading out, spreading out. So it'd be B. And then this one, forever, never, 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 in that direction, forever. And in this direction, forever, right? So it's all of the values for this one as well, all right? And for this one as well, it keeps going this way and this way. It'll keep going that way forever and ever and ever and ever and ever. So yes, it's all B, C, and D on that one. Which graphs have a range of all real numbers? Okay, all real numbers could include, for your range, which means your y values. Which y values could work in this case? For all of your all real numbers. So which y value? Here's a y value that it's everything below that. It's certainly not this one, because this is a span of y values that could work. Go to your y-axis and see which numbers work. Well, this one's less than this value. This one is everything above and everything below, and it's all of the y values, yes, on C. This one actually looks like it would be everything this way, but the weird part here is that it actually will approach this 0 axis but won't cross it. It'll just keep going flatter and flatter and flatter, but it won't ever go past the 0. So technically that one is not including all the y values. So C is the only one. C right here, which graphs have a range of only positive numbers? Only positive numbers for the y values. The y values that have positive, this one, this is the only one that is limited in the positive axis. Here's negatives, there are some negatives represented here. This one is only above the x-axis, which means all positive values. Which graphs are not functions? A is the only one that is not a function. It doesn't pass the vertical line test, right? So as I slice through right there, it's actually going to go through at 2 points. If it goes through at 2 points, then it is not a function. That's the only one that